in 1D motion. So now just we are going to see some applications, just like if I'm just going to think that we are going to apply some applications, we want to find some applications in the calculus, how to just apply that things. Let us think that if I'm just going to think that relation between the time and distance, relation between the time and distance is equal to time is equal to alpha x square plus beta x. This is the relation I can have like this way. Okay, I'm observing that this is the time, x is the distance, this is the relation between the time and distance. In this situation, whenever a particle is moving, then from there you have to find the acceleration or retardations we have to find from these conditions. Whenever the time is having a relation with the x is my distance, I'm going to see that. So now see here, actually we have to, this is a MCQ actually, basically it's just, we can see that it is a MCQ. So if I'm just going to find the retardation, you have to prove that retardation, suppose a retardation is equal to 2 alpha v cube. Show that. You have to show 2 alpha v cube. If I'm just going to have, this is my retardation, you have to show that 2 alpha v cube. Okay, just like see now, if I want to find this thing, if I just want to prove this thing, what to do? This is a time. So let us think, first of all, differentiate the time with respect to x, dt by dx. So what to do from here? D dx is equal to alpha x square plus beta x, isn't it? You can see that if I'm going to differentiate, alpha is going to come, because alpha and beta is constant, alpha beta constant, t and x are variables, so alpha is going to come out dx square dx plus beta dx dx. Okay, so what I'm going to get, alpha into 2x plus of beta, because dx 1. Okay, so you can see this dt by dx means what? 1 by dx by dt, isn't it? So dx by dt means velocity, 1 by v. So we got a relation that 1 by v is equal to 2 alpha x plus beta. Okay, fine, very good. So now see, if I want to find the retardation, so just multiply the v. 1 is equal to 2 alpha x into v plus beta into v. We're going to get this kind of a relation from here. We are going to get a relation like this way. Okay, so 1 is equal to v into, ultimately just we can write like this way, the v into 2 alpha x plus beta, that is equal to 1. So now if I again differentiate left hand side and right hand side, just differentiate. If I differentiate 1, it is going to come 1, it is going to become 0, because it is a constant number. Again, if I am going to differentiate this one with respect to t, because initially this t I have differentiated with respect to x. In the second case, when I am going to differentiate this thing with respect to, I am going to differentiate this one in the right hand side with respect to time. So how to differentiate? d dt into v plus 2 alpha x plus beta. Okay, this is the thing. Fine, very good. Now see what to do from here. First of all, v, I'm just going to take this one, d dt of 2 alpha x plus beta plus 2 alpha x plus beta into differentiate, I'm just going to differentiate v, dv dt, rate of change of velocity with respect to time, isn't it? Actually this is the thing I want, dv dt I want, rate of change of velocity with respect to time, I want this thing, dv dt. Okay, So now this is my acceleration. Now ultimately you can see, whenever I'm going to think, that v is equal to, if this part I'm going to differentiate, what the thing is going to come, 2 alpha dx dt, okay, and rate of change of beta with respect to time, this if I'm going to differentiate this one, it is going to come 0. So 2 alpha constant, it is coming out dx dt. So dx dt is what? It is a velocity. So now you can see that 2 alpha x plus beta is equal to 1 by v. So we can put 1 by v, and dv dt, that should be the acceleration, retardation, what we can say. So now from here, this is what? This is what? dx dt is what? V. So we can write v into 2 alpha into v. That should be equal to plus a by v is equal to 0. So we can write like this way: 2 alpha v square is equal to minus of a by v. So we can write a is equal to, just cross multiply this one, minus 2 alpha v cube. You can see this is the thing. Actually, already it was told it is positive because it is taken as the retardation already. That's why the sign is not important. But here it is the negative sign, implies that it is a retardation. So expression of the rate of change of velocity here is equal to minus 2 alpha v cube. So this question can come as our a MCQ form. So this option we have to tick mark. These options we have to tick mark. I think the children, it is clear to you, isn't it? I think it is clear. Very nice. Now the next question. Next question. Let us see. You can see that suppose a displacement x of a particle moving in one dimension under the action of a constant force. Okay. So displacement is going to occur in one dimensional motion. It is in the x direction. X, suppose I am to think that x, okay, a displacement is going on, and under the action of a constant force, what we can tell, F force, F is constant. It is a constant force acting on an object and a particle moving in the x-axis. So it is a 1D motion, one dimensional motion. Okay. Now a relation is existing that time is equal to root x plus 3. Time, it is the expression of the time, it is having a relation root x plus 3. This is the relation. There is a relation given, time, expression of the time is equal to root x plus 3. It is given. So now the question is that we have to find the displacement of the particle. We have to find the displacement of the particle when the velocity is 0. So you have to find the displacement. Displacement when velocity is equal to 0. And that condition we have to find out. See, just like, see, if I want to find the displacement when the velocity is 0, first of all, in this kind of situation, what to do? T minus 3 is equal to root x, isn't it? So if I just going to make it as a square, t minus 3 whole square is equal to x. So x I can write t square plus 9 minus 60. Just making the square. Just both sides I've just done the square. So we got a relation. X is equal to, it is a function of time, the displacement is a function of time, x is equal to t square plus 9 minus 60. Okay. So now what to do from here? If I want to find the velocity, because we have to make the velocity 0, and at that instant of time, the time we have to find, dx dt is my velocity. Okay. So d dt is equal to t square minus 60 plus 9. Okay. So if I differentiate t square, we will get 2t minus 6. Because if I just differentiate 9, it is going to become 0. So if I differentiate 60, so 6 is coming out, dt by dt 1. So only the 6 remaining. So this is the expression of the velocity, isn't it? So now condition is that when the velocity is going to become 0, so what we are going to get? v is equal to 2t minus 6. If it is going to become 0, the 2t minus 6. So t is equal to 6 divided by 2 minus 3 second. In this condition, 3. So velocity is going to become 0. Velocity is going to become 0 when the time is 3. Okay. So now the question is that when the velocity is 0, what is the displacement? Now just like see, we can observe the expression already we have found, the expression of the displacement in terms of t. So x can be written as t minus 3 whole square mane 3 minus 3 whole square. That mane x is equal to 0. So when the velocity is going to become 0 and the displacement is 0 in that situation, time is 3 seconds. I think children, you are understanding my point. What thing we are discussing, you are understanding my point, isn't it? I think you are understanding. Very simple question. Very simple question. Still, if you have any doubt, you can ask us directly to the Vidyanest. We are just going to help you. Okay, fine, very good. Now see, just like examples, we can have a lot of examples like this way, which can come in some competitive exams or in the board exam, anywhere. This kind of things can come. Now, the next question, we are going to come into the next question. A particle moving along x-axis whose instantaneous speed given by particle moving along x-axis, 1D motion, one-dimensional motion, particle moving along x-axis. So its instantaneous speed, it can be written like that: v square is equal to 108 minus 9x square. What is this v? What is this v? V is the velocity. V is the velocity here. We can tell it is the velocity, but speed we can tell here. Okay, in this situation, it's the speed. Now, and x is the, we can tell this is the displacement, and x is the v is the velocity, and x is the displacement. We can write in this situation. Okay, so now we require the expression of the acceleration in terms of displacement. What we require? Expression of the acceleration in terms of x displacement. Okay, fine, very simple. So now just like if I want to find the acceleration, just differentiate this one, dv square dt. So we can going to differentiate this one also, d dt is equal to 108 minus 9x square is equal to minus 9 dx square. If I'm going to differentiate with the time, what we can do? dv square dv into dv by dt, isn't it? So if I'm going to differentiate this one, dx square, we can write like this way. Dx, chain process, dx dt. dv square dt, mean 2v. I'm going to get 2v, and dv dt, what is this thing? This is the acceleration, rate of change of velocity, mean acceleration is equal to minus 9 into, if I differentiate, ddx of x square is equal to 2x, isn't it? And this is my acceleration. Oh, sorry, this is my velocity. So this is 2x. This is 2x. This part is 2x. If I differentiate this one, this is 2x. And dx dt is equal to my dx dt. This part is my velocity v. So this v are going to get cancelled. Okay. So now ultimately this 2 and this 2 getting cancelled. So acceleration can be written minus of 9x. That's simple thing. Acceleration can be written as, so it is a function. So acceleration is a function of x. Acceleration is a function of x. It can come in that manner, in that form. They can give you like this way. This kind of questions they can give you. Okay, very good. So we found that acceleration is minus 9x. Fine, very good. So now see the next question. I think it is clear. I think children, it is clear. Okay. So simple differentiation, we are using the simple process of the differentiation. Okay, now the next part, next question we are going to have. Let us think that a body actually let us think this a body is in a motorboat. Motorboat, it is moving in the water and it stops the engine. When the engine stops, a motorboat, there is a motorboat, it was moving in the water, it stops the engine. Whenever it stops the engine, what thing is going to happen? Immediately there its acceleration stops. There is no acceleration naturally, but some friction is existing in the water, so retardation starts. The retardation starts, whenever retardation starts, that retardation can be written as dv dt is equal to minus kv cube, like this way it is given. And at the instant, at that instant, whenever the engine stopped, at that instant velocity it was possessing, that is v naught. Okay, at that instant the velocity, when the engine stopped, the velocity at that instant is v naught. So now, so now, we have to find magnitude of the velocity after time t. Magnitude of velocity after time t when engine stopped. When the engine stopped. Okay, but we have to find the magnitude of the velocity. Now see how to just find this one. So this is my acceleration. Actually, this is a retardation. Actually, dv dt, dv you can see by dt is equal to minus kv cube. So you see that dv by v cube is equal to minus k dt, isn't it? So just we are going to do the integration both sides. So v to the power minus 3, so v to the power minus 3 plus 1 divided by minus 3 plus 1. Okay, now is equal to minus kt plus something constant, suppose integration constant, because we have not given the limit here. We have not applied the limit here. So minus 2 plus 1 is minus 3 plus 1 is equal to minus 2. And v to the power minus 3 plus 1, v to the power minus 2. Tale minus kt plus c. Now see, we are just considering the motion when the engine stopped. We are going to count from then. Time counting start from when the engine stopped. So at that time when the engine stopped, we just going to consider time is equal to 0. And at that instant of time, the velocity was v naught. Velocity was v naught. So what we can write it here? Minus 1 by 2 v to the power minus 2 mane v 1 by v square mane v naught square is equal to, if I am going to put the time 0 mane starting time, this is 0 plus c. Children, I think you are understanding my point. I think you are understanding my point. Okay, so now just like we can write it like this way. We can write it like this way. How to write it like this way? How to write? We found the expression of the c. That's why we can write 1 by minus 2 v square is equal to minus kt, and the value of the c is equal to minus 1 by 2 v naught square. So here is also negative, here is also negative, here is each and every one is negative. So we can put the negative sign, we just can cut both sides. 1 by 2 v square is equal to kt plus 1 by 2 v naught square, isn't it? Okay, so just now in this situation, uh, we got an expression of the velocity. We've got an expression of the velocity v at the time t, because this time is variable. So 1 by 2 v square is equal to, just put this one up, 2k v naught square into t plus 1 divided by 2 v naught square. 2k into v naught square into t plus 1 by 2 v square. So we just can have like this way, these two cancelling out, the v square is equal to v naught square divided by 2k v naught square t plus 1. After t time, when the engine stops, the expression of the velocity is going to become the root of, if I just going to make the root, v naught square is going to become v naught, and this is going to come 2k v naught square t plus 1. So final expression of the velocity after time t is v naught divided by root over of 2 v naught square kt plus 1. So after t time, when the engine stopped, after that, after t time, when the engine stopped, we are going to have the expression of the velocity like this way. We can have like this kind of expression of the velocity. Okay, I think the children, you're going to get my point. Very good. Now see, if you have any doubt, if you have any confusion, if you have any kind of question regarding or you have any your doubt or questions, you can contact us to the Vidyanest. We are ready to solve your questions. Okay, or still whatever we are going to discuss, if you have any kind of doubt or confusion, you can ask us, no problem. Okay, now see, you can see, suppose a particle moving in a straight line, we have velocity displacement graph. This is my velocity, this is my displacement s. Suppose I can take x also, no problem. V is the velocity. Now see, this graph is like this way. Velocity displacement graph like this way. It is not necessarily this way, just I am going to think that I can have a curve also. Not every time, because some straight linear graph, just in the previous class we have discussed. Let us think this is this. Okay. Let us think at a certain point I am going to have a tangent. I am going to have a tangent like this way at this point. Okay. And suppose this is a 3 and this is a 4. I can think this is a meter per second and this is the only meter. Okay, this is, I'm going to think that this is a 60 degree. Okay, that this is a velocity displacement graph. Let us think that I'm going to change the color. This is the graph, and in the graph, that tangent at this point, that's tangent velocity displacement graph, and the coordinate of this point where the tangent has drawn, that I'm going to have, this is a 3 and this is a 4. Children, tell me, I have got a coordinate of this point 3, 4. Very good, very nice, no problem. 3, 4, we have got a coordinate 3, 4. What does this means actually? What it means actually? If this is 60 degree, if this is 60 degree, this angle is 120 degree. So rate of change of velocity with respect to displacement, can't I tell? It's the slope of the graph. 10, 120, isn't it? Any confusion in this one? Because we have discussed any graph is there. If I develop a tangent at that point, slope of that tangent, what is the slope? This one, this angle, tan of that angle. So this is the slope. So slope of that tangent line is the rate of change of velocity with respect to displacement in this situation. Already in the previous calculus class, we have discussed this thing. Rate of change of velocity with respect to displacement is this much. Now, question is that what is the acceleration at s is equal to 3 meters. From this data, we have to find the acceleration. Now see, it's like dv by dt into ds dt. Okay. But because dt cancelling out, just I'm going to little bit shift delta s ds by dt. So what is this thing is actually, this is the acceleration. dv dt is the acceleration. This is my acceleration divided by ds dt, isn't it? What is this ds dt? This ds dt is velocity. So acceleration by velocity is equal to 10 120 degree. Okay. তাহলে acceleration is equal to v into 10 180 minus 60 degree. You can see that. You can see that. When the displacement is 3, velocity value is 4. You can see this one, this much is velocity value is 4. So, because they told that you have to find the acceleration when displacement is 3 meter. So, when the displacement is 3 meter, I can have that velocity value is 4. Okay. So, we can write like 4 and 10 180 minus 60 means what? Minus 10 16. Just simple trigonometry. Minus 10 16. So what it means? Acceleration is equal to minus 4 into tan 60. What is this tan 60? Root 3. In this situation, we can write minus 4 root 3 meter per second square. So if this kind of graph is going to come, you have to understand that rate of change of velocity with respect to displacement is the slope of the graph, and from the slope of the graph we are just arranging this system, and from there we are finding the acceleration. I think it is clear, children. If still not clear, you can ask me. If you're just going to think that you have the confusion like this kind of questions, you can ask me, no problem. I think it is clear. Everybody clear, isn't it? I think it is clear. Okay, fine, very good. Now see that the next question, and every time I'm going to repeat that. Whenever you feel that some doubt is existing, you definitely contact us. We are just going to help you, no problem. So now see that suppose velocity displacement graph I'm going to have. Just previous one we have seen that velocity and we have taken this is a yes, previous one was like this way, curve. Now we are just going to think that no, I'm not going to take that curve. I will take a linear relation like this way. This direction I'm going to take that velocity. Okay, I'm going to take the y-axis velocity, x-axis s. Okay, so in this situation, if I'm going to see that curve, velocity and s curve, it is not a curve, it is a straight linear. It is a really linear relation. So now mean, what we can write like V is equal to, if this length is V naught, V naught plus M into S if the slope of the curve is theta. So M is equal to tan theta, isn't it? So V is equal to MS plus V naught. Fine. Now the question is telling that it is an MCQ pattern question. Acceleration of the particle option, acceleration of the particle constant. Second option, acceleration is related linearly with displacement. Acceleration related linearly with velocity. Option 4, none of this. Okay. So how just we can have like this way? How just we can find the relation whether the constant in this situation when the velocity and displacement is just related like this way, whether the acceleration is constant, we have to find whether it is related linearly. But linearly means just like velocity and displacement, just linear relation existing. So in this situation we have to find whether the acceleration is related linearly, whether acceleration is related linearly with the velocity or displacement, or none of this. So simple thing, just like see, if I'm going to find the acceleration, we are going to differentiate this way, dv dt. Differentiating rate of change of velocity. So now just what the thing is going to happen, d dt m into s plus v naught. So what the thing is going to happen here, you can see this dv dt by acceleration. Now m is a constant, it is coming out ds dt, and you can see this v naught is a constant, it is 0. So ds dt is what? Is the velocity. Ds dt is the velocity. The acceleration is equal to mass into velocity v. Therefore, I am just going to shift m. What is the velocity is? Ms plus v naught. So acceleration can be written like this way, m square s plus m v naught. You can see the m is a constant, v naught is a constant. M square, m is the constant, the square of it is a constant. A is a variable, displacement, a is a variable, acceleration. So therefore this part constant, this is a constant. So acceleration is also related in a linear manner with the s. So option 2 is correct. So option 1, it is not possible, that is a constant. No, it is not possible. None of this, no, it is not possible. Now I have to check that whether this one is going to have a relation. Acceleration, is there any relation with the velocity? We know that the rate of change of velocity is equal to acceleration. That we know. That we know. Definitely, you can see already we formed. M is a constant, isn't it? M is a constant. The acceleration is directly proportional to v in this situation. Directly relation. So just we can have, if I just plot a graph, acceleration displacement, it is just like going to like this way. Because m square, a little bit m is like this way, and acceleration velocity, if I'm just going to plot a graph, acceleration velocity, I can have like this way. So these two options are correct. So this is a multiple option correct. It is a multiple option. This option simultaneous, sometimes since WBJE or some exams, multiple option correct comes. So you have to check. In that situation. So whether this is correct or not, is if the multiple options are correct or not. Okay, very nice, very good, very good. Now, just like, see, if I'm going to think that I'm going to have an acceleration time graph, okay, acceleration time graph. So you can see, if I'm going to have an like this way, this is the acceleration, this is the time, you can just like, this is a graph, acceleration time graph. So particle, suppose moving in a straight line, and I'm going to observe that the particle like having like this way, this particle having that this kind of relation is existing. Okay, suppose I'm going to see that this part is the a, this is the a naught, this is the b naught, this point. So what we can find from here, in that in this kind of situations, when the acceleration is reducing, when the acceleration reducing, you can observe this is not a constant acceleration. So what is the relation we can have? Acceleration by a naught plus t by b naught is equal to what? Straight line relation, straight line equation. So acceleration by a naught is equal to 1 minus t by b naught. So we can write like this way: acceleration is equal to a naught minus a naught by b naught into t. We are just observing this one. Now, what we can observe from here, if it is informed that we know that acceleration is equal to rate of change of velocity with respect to time, a naught minus a naught by b naught into t. Okay, so dv is equal to a naught dt minus a naught by b naught t dt. Okay, you can observe that whenever I'm going to take this point, at this point the acceleration is going to become 0. At this point acceleration is going to become 0. Okay, if this acceleration is going to become 0, what we can have from here, if it is told that initial velocity is existing, suppose v naught, initial velocity when the time is 0, so integration v naught is equal to a naught integration dt minus a naught by b naught integration t dt. So a naught t plus a naught by b naught t square by 2 plus something constant is equal to v. Okay, so now if it is informed that, initially it was having some velocity when the time was 0, it is a v naught. The time, if I put the 0, we can have v naught is equal to c, because this part is going to become 0 because tt is existing there, isn't it? So now what to do from here, I am going to get a expression of the velocity is equal to a naught t minus a naught by 2 b naught t square plus instead of c we are going to put the v naught. Okay, now in this situation, if the question is going to ask that after starting the motion, what is the displacement, what is the এটা হয়ে যাচ্ছে, এটা আমি এক্ষুনি শেষ করে দিচ্ছি। So now see, the v is equal to a naught t minus a naught by, so now if the question is asked within that, after starting the time t naught, after the starting the time, what should be the displacement has occurred from the starting 0 to t naught time. So what we can get from here, v is equal to a naught t, well, d dt, one displacement, rate of change of displacement, that is the v, is equal to a naught t minus of a naught by 2 v naught t square plus v naught. So let dx is equal to a naught t dt minus a naught by 2 v naught t square dt plus v naught of dt. So now integration, if initially starting the displacement was 0 and final displacement is x, so what we can get from here, within a time t naught, 0 to t naught, 0 to integration t naught, integration 0 to t naught, we will get the total displacement during this process, x is equal to a naught into t naught square divided by 2 minus a naught by 2 b naught t naught cube by 3 plus v naught into t naught. So this is the displacement is going to occur when the particle started with the velocity v naught at the time t is equal to 0. We will get the expression of the velocity like this way, and after that we are going to get the total final displacement after starting within a time period of t naught, from 0 to t naught. This is the expression of the displacement we can have like this way. I think children, you are getting my point.